Okay, we're live. Welcome, everyone. Excited to be back here with another Infinite Layers. And today we're joined for the first time by a guest that we've already had on, and now we're here to talk about a lot more. So welcome today. We're here with Ismael from Lagrange. Would you like to give an intro again for people that might not already know you or have seen our last episode?
Yeah, thank you so much for having me, Nader. And I'm excited to be back on. So my name is Ismail. I'm the founder of Lagrange Labs. We are a company that builds universal general purpose proving, as well as very specific products on top of that, including our coprocessor and our state proofs. We've been building the Eigen ecosystem for a long time across all of our products. And the EigenLayer team is one of the groups that's been the most supportive of us for the duration of the company. And we're highly excited to always be talking about some of the great work that we aim to do in the ecosystem.
Awesome. Well, so when I first started Infinite Layers, I think you were either my first guest or one of my first guests. So it's been about 7 months now, and I've been here a long time, and you all have been building a lot. So a lot has kind of changed. So we're kind of bringing you back on here to talk about a few things. First of all, we want to talk about Lagrange. Second of all, we want to talk about the updates that you have. And third of all, we might just talk about the EigenLayer ecosystem a little bit, because you've been here longer than anyone. You've been one of the biggest supporters. You have a lot of knowledge. You've been to all of our events. You've just been a great participant and contributor to everything. And then we had the recent developer report come out, kind of highlighting the growth in the EigenLayer ecosystem. And we can kind of maybe chat about some of that stuff. So to get things started, let's go back a little bit and just give people another quick introduction to like your own background and how you came into start Lagrange.
Yeah. So when I started in crypto, I felt that the things that you could do on chain, on Ethereum, on L2s, were limited. The things you could build were fundamentally constrained by the access to data, the access to computation, and the access to scalability. What we had started to believe as we continued to kind of develop in the space was that the way to solve these existing issues was through zero knowledge. Through zero knowledge compute over data, through scaling blockchains, through general purpose zero knowledge compute, and through scaling interoperability and securing interoperability through zero knowledge proofs. And so when we started, we were hyper focused on specific problems that we saw in the space that we believed could be solved with ZK. Those problems being interoperability and access to historical data. Interoperability we addressed with our state committees and state proof products that we now integrate with Layer 0, AltLayer, Polymer, and some of the top interop protocols in the space. And we are also obviously working with our coprocessor, which is another thing we deployed in EigenLayer, with many of the top DeFi and NFT projects. Groups like Azuki, Sappy Seals, Gearbox, EtherFi, Frax, etc. And over time, what Lagrange has continued to do was expand into opportunity. And where there is a fantastic amount of value that can be really delivered in the space right now is through decentralized proof generation for ZK rollups. Fundamentally, how do you take what is one of the most transformational technologies in crypto today, ZK rollups, and make them more secure? Higher liveness guarantees, less censorship resistance, and more cost-effective and user-friendly than ever before. And that's what we have been expanding into with Lagrange's infinite proving layer. How do we take the core competencies in the production-grade decentralized proving that Lagrange has today, and how do we apply that to make it as impactful as possible to as many people as possible in crypto?
Got it. So the infinite proving layer is kind of an expansion of Lagrange.
Exactly. We deployed our prover network in production in EigenLayer in June. We now have 85 top institutional operators generating decentralized proofs for our coprocessor and our state committees and our state proofs on top of our existing production decentralized network. What we've since done is we've really reinvent the architecture, revitalize a lot of kind of the core designs that we've embraced, and to apply that for rollup proving and for really any type of proving you want to do on top of Lagrange and on top of EigenLayer.
Got it. So before we dive into the new portion of this, can you maybe highlight what people are using, maybe the state committees and the state proofs? Like what are some of the use cases and what people are kind of building with that?
Yeah, that's a fantastic question. So the state committees and the state proofs really are a way to secure the state of a rollup, the secure representation of the state of a rollup that you use as part of interacting between chains. So the question for all interoperability protocols is, how do you take an assertion of state from chain A, so representation of state that we're going to trust, move that to chain B and do something with that? We can check a message for a messaging protocol. We can check a transaction for a bridge. We can check state for some type of stateful bridging. Well, the security of that is entirely predicated on how do you take the assertion from chain A and move that to chain B. And so what the state proof product does is create a assertion of state based on proofs of restate security that are testing the state of a rollup. So you want a message from Optimism to Arbitrum, and you want to use the most secure form of state possible. Well, you can use the state proofs that we have that have 10, 20 billion of economic security, but actually it's about 16 billion now of economic security that's obviously restaked into those. And so we're not a messaging protocol, we're not a cross-chain protocol, but what we can do is we can take these proofs and we plug them into existing protocols. So we're plugged into layer 0 as a DVN, we're plugged into AltLayer as part of their gateway protocol, and we're plugged into Polymer as part of one of the sources of state that they use. So basically, we let them push off of the dependency on where they get their state from onto us to give them a proof of a secure representation of state that they can then consume in their application and use to authenticate cross-chain messages.
Okay, got it. And I would say from what you all had essentially started with to kind of get to where you are today with this new expansion, kind of what led to that? Is it basically you all built some of this infrastructure, you built some of this functionality, and you kind of have these primitives, and then you can now kind of take some of that and expand it? Or was it kind of building from scratch? Like, did you expand maybe what you already had there, or did you kind of like restart?
Yeah, so we actually launched the first, I believe, decentralized prover network actually in all of crypto into production on EigenLayer in June. And so that network was specific for products that Lagrange built, the coprocessor and the state proofs, that was responsible for generating decentralized proofs for those two core products. Almost immediately after that, we realized that the market for generating decentralized proof was much larger than just the product that Lagrange built. And we started working to expand the production network that we have, expand the operator base, and expand the functionalities of it to be able to support decentralized proving in a market for really anybody who wants to do
that makes sense. So essentially, someone could go and build their own old Lagrange on Lagrange.
Exactly.
Okay, cool. So I think you have a presentation that we can dive into, and then hopefully from there we can get more specific around some of these questions. So do you want to share your screen and go over some of this?
Yep. Let me dive into it right now. Slides coming up right now. Perfect. So this is hopefully the first time that people are seeing these slides. It's the first time our ecosystem, I think, is seeing these slides. So very excited about being able to dive into this. And so generally, I kind of like to start a little bit with a story. So several years ago, when I was founding Lagrange, I was in San Francisco at the time, and someone told me that the way they saw the space evolving was that in several years, every chain was going to be, or every protocol was going to be a cross-chain protocol. At the time, the feeling that I had was that it was, a little bit unlikely. The idea of an app on Polkadot composing with an app on Cardano was likely not going to happen. But what we eventually saw was that the evolution of the roll-up vision of Ethereum and the way that kind of the EVM landscape developed, we've separated execution, we've separated state, and almost every app that exists in EVM now is a cross-chain app, right? It takes a bridged asset at some point in its design, or it will use state, or it will use messaging logic that connects to a different chain. There are very few apps that exist today that don't have some cross-chain dependency. And so when I look at crypto today, I really kind of think that we can see an equally prescient trend, and that being that in the next several years, every application will become a ZK application. It will use state that's proven on chain through ZK TLS. It will compose on top of cross-chain data that's proven with state proofs. It will, sit on an execution space like a ZK rollup or an L1 that has the execution proven within a ZK EVM or a ZK VM, or it will sit on top of historical data, and it'll compose on top of data proven with the ZK coprocessor. But at some place within its core function, it will use ZK, right? And these apps will no longer even be ZK apps. They'll just be apps that exist that have zero knowledge core to them. And so what I think of Lagrange as is this universal layer to help unlock this proof-based future. With core products that Lagrange builds, like our coprocessor and our state proofs, as well as the ability to have low-cost universal decentralized proving, you can think of it almost like a universal base layer, an L1 for proving, that people can deploy markets on top of to generate these proofs. So we think of Lagrange as this kind of universal single layer for decentralized proving, this kind of the substrate to this proof-based future. And so what we've developed was what we think of as this highly modular and infinitely scalable market for how you can match demand for proving with supply-side resources for proving. We've developed it to be as universal as possible and as scalable as possible, starting obviously with our core products that we've had production decentralized proving available for the last 6 months, and now expanding that out to roll-up proving to be able to give really any ecosystem access to production-grade decentralized proving with high liveness and censorship-resistant guarantees. And so, the way we like to think of it is you can really kind of prove anything now with Lagrange. You can be a DeFi protocol that can access historical data by using our coprocessor. You can be an NFT protocol that builds new collections and new kind of exciting products using our ZK coprocessor. You can be a cross-chain protocol that wants to use more secure state for your interoperability using our state proofs. Or you can now be a rollup that wants to have high liveness guarantees, no censorship concerns, and low-cost proof generation that's very easy to integrate with, that can sit on top of our rollup proving layer. And so just very broadly speaking, any place that you kind of want to get zero knowledge compute within your application, you can really turn to Lagrange and you can consume from our product suite. It's almost like a cloud for proving, but decentralized. And so, we currently are working with many of the top, obviously, EigenLayer operators in the space. And like I always say that, Lagrange is a company that sits on top of Eigen. You sit on the shoulders of giants. And so, we obviously have Coinbase, Kraken, OKX, P2P, Figment, many of the top institutional operators in the space sitting on top of Lagrange that are generating proofs across all of our product suites.
So before you keep going, so do you see do you see in the future the potential for other companies to build their own, like I said earlier, maybe state committee and ZK coprocessor implementations on top of this new network?
Yes.
Yeah.
Yes, we 100% do.
That's the whole idea, right? Like, and then what else? Like, what else could they build other than like, what are some other verticals or products?
Yeah, like ZK TLS is one that I'm very, very excited about. We've spent a lot of time with Opacity, which is a team, Hirsch, I think, is one of the most exciting up and coming operators in the space, in my view. And obviously they are evaluating the centralized proving, and I like to think that some of that will be done on Lagrange, if not a lot of that. A lot of the ZK VM teams, there's people always know Succinct and Risk Zero, but there's a number of other ones that I think have even more efficient underlying designs that are not yet as well known. And a lot of those have been kind of in talks with us to deploy and build on top of Lagrange. And really, I think any place in crypto where you'll be using proofs will be generated on top of Lagrange. I think in the future, even there will be an entire market for proving Ethereum blocks at some point, where every single Ethereum block, once we move to kind of the Beam chain potentially, will require an execution proof. And where is that execution proof going to come from? Likely markets or markets of markets, like Lagrange.
Very cool.
And so, I think the question you asked segues very kind of well into this idea, where there's people who've discussed this idea of decentralized proving before, but what they've presented has always been these very monolithic and kind of like very extractive designs. It's really like they have this one ginormous network that's entirely based on their own token, and they go, hey, like route all your order flow to me, and like we'll make you some proofs, and like we'll have a couple operators who stake our token, and they'll connect to like an orchestrator and generate proofs. But the problem with that is you face bandwidth constraints, you face scalability constraints, you face networking constraints, and you also face these economic limitations as well at scale. And so what we've done is re-architect that to create this idea of like this market of markets, or this network of networks, wherein you can have these sub-networks that each independently run these work auctions to determine eligibility to generate proofs with bespoke staking requirements and bespoke hardware requirements that are each identical and replicated, such that across all of Lagrange, you have this kind of market of markets, where we have a portion of the network doing co-processor proofs, a portion of the network doing state committee proofs, a portion of this network that will be doing Caldera's proofs, a portion that will be doing AltLayer's proofs. And each of those can be designed and operate separately as these almost independent sub-networks, this kind of like internet of proving, where in collection you have what is Lagrange.
Very cool.
And so
yeah, so I mean,
this,
like the way I look at this, almost it's kind of like you have the analogy of the like super chain, and then you have optimism. Like optimism is a product built on the super chain, and this new network exists a product that is the previous product of Lagrange, but now anyone can build their own network. Yeah.
That's exactly it. You actually 100% identified the entire business strategy that we were going for.
Awesome.
The optimism example is the one that we actually have used. You're the first person actually who just immediately gravitated towards that. I love that. But
awesome.
Yeah, that's the one that we often kind of talk about as well, where you have this idea of optimism is to the superchain what kind of the coprocessor is to Lagrange as a whole. And so we're excited that there's going to be a base at some point, and that base is going to be as large as anything we could build. It'll just be an independent kind of economic system that someone else is going to develop on top of the stack. That's going to be accretive to us, and it's going to be accretive to them, and it's going to be something that allows them to build the business without having to build all the underlying tech. And they're going to have something that's as large as bases.
Awesome. This is exciting. Yeah, this is already very helpful for me. I've been trying to keep up with everything that you all are doing, but it's helpful just to sit down here and dive into it. So, but yeah, I don't want to stop you from going.
No, I love this. And so, I think very basic idea of how you do decentralized proving. You have a gateway that we call them the network that orchestrates proving. You have provers that bid to generate the proofs, and then you have kind of this work auction that our team has developed with this new paper called Dara that determines how kind of work is generated on top of the network and how work is assigned out. And if a prover generates a proof on time, they receive a reward. If they don't, they receive a penalty in the form of slashing and non-payment. So there's an incentive to maintain reliability and liveness for the stake that an operator has. And so, I spoiled these slides a little bit ahead of time, but you think of kind of the way people have architected prover networks before. They usually have a single orchestrator, a single gateway, and they try to clump everything into there. It creates I/O issues and bandwidth issues, and it doesn't also allow economics to be very tailored or bespoke, right? It's the idea of why if Optimism told everybody that they had to stake OP token on their chain and use OP token on their chain, Optimism wouldn't have a super chain. It's the ability to have these independent economic models that are each having isolated bandwidth that has allowed the superchain to become a superchain. And by extension, when we talk about Lagrange's as a network of networks, it has this kind of horizontal scaling with dedicated bandwidth and isolated and customizable economic environments. And so, we can really support any type of complex proving on here, all the way from our coprocessor and state proofs, all the way to ZK stack, CDK stack, any of the popular proving backends, really anything you want to prove, we can prove on Lagrange. And we can go into endless detail on kind of auction design and proof of market work that our team has done. We have a great paper on this called DARA that we've released recently. That was actually just accepted in the Financial Cryptography, which is one of the top kind of academic conferences for kind of mechanism design and the application of mechanism design within cryptography. This is the first kind of work that has an incentive compatible design for proof markets. I think a lot of people have talked about like, how do you build an incentive compatible proof market? How do you build a transaction fee pricing mechanism? But this is the first work that has actually been able to specify a set of formal properties under which something is incentive compatible, things like collusion resistance, welfare maximization, budget balancing, and then is able to mathematically prove that the mechanism that was created is able to actually satisfy those properties. So we think it's a rather foundational work. I'm sure some other great people are going to come out, hopefully, and iterate on this. And we're going to keep iterating on it. But for us, it's a very exciting moment to kind of put a stake in the ground that prover markets and prover networks are something that is a real area of study, and it's something that's real in space.
Very cool. Very cool.
And yeah, so high liveness guarantee proving on EigenLayer, fantastic economies of scale, best price guarantees, and obviously on top of things like EigenLayer's efficient payment flows and EigenLayer's secure slashing designs. It really means that we can kind of build on top of a very powerful foundation, which is EigenLayer. And so the last thing I want to cover before we kind of move into any kind of additional questions or Q&A is really kind of this announcement that we did yesterday. The infinite proving layer that Lagrange is working alongside two fantastic rollup ecosystems, AltLayer and Caldera, to be able to move their proving demand for ZK rollups onto our decentralized network, being able to reduce cost and being able to kind of build a foundational infrastructure that can kind of work with these ecosystems for the long term with just very accretive economic designs and very kind of secure and resilient proving. So we're very excited about that. And we're going to very soon be announcing even more integrations that we have on top of our decentralized proven network.
So what does the integration actually look like with Caldera? So would it be if someone decided to launch their own rollup on Caldera, they could essentially also integrate, I guess, would it be kind of like, would they be able to turn their rollup into kind of like a ZK rollup by leveraging this, or would it be something different?
Yeah, so AltLayer and Caldera currently support like Polygon CDK, ZK Stack from ZK Sync, and then Scroll Stack rollups. And so when those rollups launch, obviously the people who are launching those have to pay for the cost of doing the proving. There's an engagement cost that they have to spend that obviously has to package in the infrastructure cost. And so what Lagrange can do is we can move the centralized proving done for those rollups onto our decentralized network, where the validity proofs or the state transition proofs for the ZK stack or the Polygon stack or the Scroll stack rollups will be generated on top of our network, which will be cheaper, more secure, more cost effective, and be able to return some very positive economics to everyone involved.
Got it. Awesome. So what does beyond, I would say, the developer experience of like integrating with one of these other rollup providers, what would the stack look like for building something custom and leveraging the new network? What does that kind of look like? I know that with I would say the ZK Sync version of this, the Optimism version of this, the Arbitrum version of this, there is quite a bit of work that needs to go in to kind of make it possible for just a developer to go and build something. It's pretty complicated. Even now, it's getting better. But I'm assuming like you all are putting together some type of like stack that people can fork or they can clone or they can start with.
Yes. So right now we are developing in-house very custom integrations for very popular proving systems. So for example, if you were to talk about a ZK rollup, for example, you would have to look at how the proving is done in the centralized context, which is generally highly distributed. And you'd try to take the distributed design and then be able to apply that on top of the decentralized network. If you're already doing something distributed, so if I have like 10 machines doing something on AWS, you can, in theory, take that and build it such that you can have 10 machines doing that in a decentralized context. And so, we are very, very familiar with kind of all of the ZK rollup stacks at a very intricate level. And so we are working to make sure that every single one of those can operate in production, decentralized on top of our network, that can actually benefit from all of the great infrastructure we've built that underpins that. From there, I expect sometime probably early to mid next year, we'll just actually have an open source like Lagrange subnetwork stack where you can kind of grab that, put a proving system on top, and use that. What I also think is likely going to happen is that there's going to be a finite number of proving backends that people choose to use, and so having it be very configurable to be able to just click in a CLI, in essence, which proving backend you want to support decentralized proving for, where it's hyper optimized to run on top of the network and hyper optimized from query planning, scheduling, and kind of the execution side of things. That's likely going to be the most developer ergonomic way.
Got it. Makes sense. Cool. So, yeah, this has been really great. And so we're kind of the first people to see this presentation, right?
You are. Some of the diagrams might be on our blog, but from walking through this with the full context and the full color, this is the first time we've done this. So
I think we talked about this before, but in terms of the proof verification, do you all have any opinions about that, or is it more just you kind of you just obviously are specializing in the proving or the proof creation, and then you kind of let the verification, the developer or the team to kind of choose that on their own? Is that how that works?
Yeah. So we focus on kind of just the question of decentralized proving. And I think the question of verification is an interesting one because you can actually develop it in different ways. Almost every ZK proof right now that's used in crypto eventually gets verified on Ethereum. There's teams like AltLayer or ZK Verify or Highly that are trying to change that and have stuff be verified elsewhere. But right now, almost every ZK rollup proof will eventually be settled on Ethereum. Every coprocessor proof will settle on either Ethereum or on an L2 that eventually settles on Ethereum. So almost everything kind of just all settles down to the place that has the highest degree of economic security behind the state transitions, which is Ethereum. So kind of all roads lead to Ethereum. And so we're kind of unopinionated on where you choose to verify your proofs once we deliver them to you. I think it's very likely that we'll see like very complex aggregation layers being built that will also all settle to Ethereum. Things like AgLayer, Elastic Chain, etc., do actually eventually get to Ethereum. But it's also very possible that we'll see kind of these alternative layers like AltLayer and Highly and ZK Verify at some point. We'll support really anything that our customers want. We try to be incredibly neutral, decentralized, and really the type of product that people can feel comfortable building on for the long term.
So right now, there's a lot of hype and talk around AI. What are your thoughts around how AI and ZK, how they sit, like what kind of synergy they might have, and what do you see the future being in terms of those two technologies, being synergistic in general?
Yeah, I love that question. I actually should have probably said AI earlier when you asked me about other verticals that I was excited about. I'm actually very excited for the intersection of AI and ZK. My controversial take is that it's one cycle away, probably. That we're seeing an explosion of AI with crypto economic security, AI with TEs, and kind of agents being used on chain. I think the infrastructure for ZKML is still nascent. And I know people might think AI, I saw one of the comments from here that AI is a bubble, and it might be, but long term, I think AI is directionally correct. And there's going to be AI that's going to be used in 10 years, 20 years. And that AI is going to be used on chain in 10 years and 20 years. And I believe it will be proven on Lagrange in 10 years and 20 years. Will it be proven on Lagrange in the next 6 months? I don't know if people are going to really want to pay the overhead for ZK to prove AI in the next 6 months. But if we look, over very long cycles, I think it's very likely that it will eventually move to be verifiable.
So yeah, I was having a discussion with someone, and they were essentially arguing about the fact that this was a non-crypto person, that crypto has already had a lot of time to gain maturity and adoption. It hasn't, and therefore it will fail. And they were like, "Look at AI. Look how much use people get out of AI." And I'm like,
Yeah,
AI has been in development for like 40, 50 years. It's like,
I
and if you kind of
know.
look at the adoption curve of AI versus crypto, we're actually on a faster adoption curve. But when you
We
look at
are.
ZK, it's even obviously earlier, but you also are looking at the progression of
Yeah,
ZK, like relative to crypto and then
exactly.
relative to AI is actually going faster as well.
Exactly. I mean,
So
Deep Blue beat Gary Kasparov in '93, right? So that's 30 years ago, or '97. Sorry, so like 27 years ago
right.
was when we decided that AI was better at chess than the best chess player, and it's taken that long for us to have sophisticated chatbots.
That's a good point. Yeah. So everything is relative, or you kind of have to just maybe
Exactly.
have a broad understanding of like other similar technologies, and it is interesting. You kind of like see these waves of adoption, and right now we're kind of seeing the crypto market um, come back with more like regulatory certainty in the U.S., but also it just kind of when it gets its tentacles into something, it never really comes out. And every time there's a new wave of adoption, the tentacles get deeper and deeper. And I think that's
Exactly.
kind of how this is going to play out.
I totally agree. This is what makes me very excited about EigenLayer as a company and as a platform. I really feel like the ability to take what is the largest pool of crypto economic security and purpose that to building this marketplace for trust that sits on top of Ethereum as a base layer is one of the most powerful primitives that we can actually access in the space, because it's true to what Ethereum is best at, right? Ethereum is this,
Absolutely.
this high trust layer behind every state transition, and we're able to then take kind of that trust and build a substrate under which it can be kind of be freely purchased and sold. And so, I think with Lagrange, we really believe that by taking that kind of that marketplace for trust, we can purpose that to building this marketplace for proving, and this global marketplace for proving. And I know you've talked about it, and Shriram's talked about this idea of this verifiable cloud. And I like to think that within that verifiable cloud, you have kind of this cloud of ZK. And I think that's what we built.
That's a good analogy. I think that you all should talk about that analogy a lot, and also kind of draw the analogies between these roll up stacks. I think that's a really good analogy, just because it's true and it's really easy for people to understand, because it took them time to even draw those understandings, and
Yeah,
you don't want to kind of start from scratch. So, but yeah, those are just some general thoughts after watching this.
I love that. I really appreciate that. I think you've been one of the people I always like to defer to when you suggest something. It's usually right.
Well, this has been really great. I learned a lot, and I'm assuming that everyone here that chimed in learned a lot. So,
Mhm.
if someone's a developer or a company, or they're just someone that might be interested in learning more, and they want to go somewhere to dive a little deeper, what
Yeah.
would you suggest?
Yeah, I think that every app is going to be a ZK app. And so the sooner people kind of understand at least the developer flow of working with ZK, the sooner they'll be able to build something that's durable in the space and that can last across cycle. And so what I like to think is when someone is saying where is the right interaction point with Lagrange, it has to do with kind of the depth of their existing understanding of this technology. And so if you're a first-time developer who's building a DApp and you want to use ZK, use the coprocessor. Write some query in SQL of historical data. Very simple. Oh, did we cut out?
You are back. It was
Okay.
just for a second. You're good.
All right. But if you're a developer and you want to use secure state in your DEX, you know, use the state proofs. But if you're someone who's obviously very familiar with ZK, you want to build an entire custom bespoke market for your rollup ecosystem, then you should probably contact us. That's kind of complex, and we want to work directly with you and a little bit more bespoke with you, and we want our team to kind of sit down and assist you. But also, you can also do that on Lagrange. You can have your own subnetwork that has your own token staking and a very complex economic design that ties into the generation of your proofs in a decentralized fashion that can retain all these properties of censorship resistance and these incentive compatible properties as well.
Amazing. So in terms of just following along and keeping up, Discord, Twitter, like what are some community places for people to get involved in the community?
Yeah, so we have recently started this kind of very broad community activation that we call the Lagrange Legion, which is kind of the name that we have for the people who are the core members of our community who we're building with together for the long term. And so we would suggest anyone who wants to be part of the Lagrange Legion, please join the Discord. We have a series of kind of quests under which people can participate in the Lagrange Legion and kind of be part of the journey and story of Lagrange. And I also say that if anyone wants to kind of work with us from a use case standpoint, developer standpoint, feel free to contact me or anyone on our team, and we'd love to work with you there.
Awesome. Yeah, definitely follow Ismail on Twitter. What's your handle? You want to give it a call?
Yeah, at Ismail_H_R.
Also follow Lagrange Dev. And if you chimed in late here, we will be putting this recording on YouTube within 24 hours, and I'll try to link to all these resources there, including the Twitter handles.
Awesome.
Awesome.
Thank you so much for having me, Nader.
Yeah, that was great. Thanks for your time today. Thanks everyone for chiming in and stopping by and for all the comments. That was really great. We will be back next week with another Infinite Layers. And again, if you missed this earlier part, check out our YouTube. We'll have the whole thing up tomorrow. Bye, everyone.
Thank you, guys.